Use the Taylor series formula to find the Maclaurin series of the following function. The function is natural log of 1 plus x. And we know that the Taylor series formula is given by fx equals sum cn x minus center, which is 0 in this case because we are talking about Maclaurin series. So x raised to n, x minus 0 raised to n, which is just x n, where cn's can be found in this way: f nth derivative at 0 divided by n factorial. Okay, so let's find couple of constants. All we have to find is the cn's. So first, our function is given natural log of 1 plus x. We need to evaluate this function at 0, which is the center, because Maclaurin series means center 0. That is natural log of 1 plus 0, just 1, and natural log of 1 is 0. That is related to, in fact, n equals 0. Then from this we can get very first constant c0, which is f0 over 0 factorial, which is 1, so 0 over 1, just 0. Next we want to find the derivative. To find c1, the derivative of natural log of 1 plus x is 1 over 1 plus x times derivative of this, which is 1, so don't have to write. Now let's evaluate this derivative at center 0. Plug in 0, so 1 over 1 plus 0, just 1. This implies c1 is this first derivative divided by 1 factorial. F first derivative divided by 1 factorial, so 1 divided by 1 is just 1. Okay, this is related to n equals 1, related to n equals 2. That means let's find the second derivative, that is derivative of this, and using quotient rule, or you can move 1 plus x to the top, which is 1 plus x quantity raised to negative 1. In either case, or you can use quotient rule, the derivative is now negative 1 over 1 plus x quantity square. That means we can find the second derivative. We can evaluate the second derivative at the center 0, which is replace x by 0, 1 square 1, 1 over 1, so negative 1. That implies our c2 will be then this negative 1 divided by 2 factorial, which is 2, or 2 factorial. Okay, that's related to n equals 2, so n equals 3. So let's find derivative of this third derivative. So derivative of this, again, when we move 1 plus x to the top, it becomes 1 plus x raised to negative 2. Then we can use the power rule combined with the chain rule, and this becomes, derivative is now 2 over 1 plus x cubed. You can try this on your own. And let's evaluate this third derivative at the center 0. Plug in 0, so 2 over 1, just 2. That implies c3 is in fact 2 divided by 3 factorial, which is 2 over 3 times 2. Because 3 factorial means 3 times 2 times 1, so 6, so it becomes 1/3. Okay, now it looks like 1 over 1, positive 1 over 1, negative 1 over 2, positive 1 over 3. Let's hope we get negative 1 over 4 in the next step, then we will be all set. Then we can figure out everything. So n equals 4, related to n equals 4, let's find the derivative of this. That will be fourth derivative. Move this to the top so that what we get 1 plus x raised to negative 3, and use the power rule, so that becomes negative 6 over 1 plus x raised to 4. Now evaluate this derivative at 0. So 0 is 1, so negative 6, and that gives us c4. c4 is this fourth derivative divided by 4 factorial, so negative 6 over 4 factorial. 4 factorial means 4 times 3 times 2, so 3 times 2 6 cancel, negative 1 over 4. Now we saw the pattern. This is 0 over 1, okay, it doesn't count. 1 over 1, negative 1 over 2, positive 1 over 3, negative 1 over 4. Okay, thus this function and etc. So thus we can write the power series now. Natural log of 1 plus x is, if we expand this, then we would get c naught first plus c1x plus c2x squared plus c3x cubed, c4th x fourth, and etc., which is in our case c0 is 0, c1 is 1, so just 1x, c2 is negative 1/2 x squared plus c3 is 1 over 3 x cubed, c4 is negative 1/4 x fourth. And now we can guess the positive negative positive negative, it would be positive 1/5 x fifth, negative 1/6 x sixth, etc. Now we want to write this in the closed form, okay, in terms of sigma notation. So n from something to infinity, look at here, x, so 1 over 1, 1 over 2, so we have, so this doesn't count, so plus minus, so that will be negative 1 raised to n. Then we need to start from 0, okay, negative 1 to the 0 is positive, n equals 1, negative 1 to the 1 is negative, okay, that takes care of that part. Now we have in the first term, when we plug in n equals 0, we are supposed to get x, so this will be x raised to n plus 1 then, because when n equals 0 we get x raised to 1, which is x. When n equals 1, the second term, this doesn't count. When n equals 1, x raised to 1 plus 1 2, and we need to divide by is 1 divided by 1, 2 divided by 2, 3 divided by 3, so n plus 1 divided by n plus 1. You can try and plug in n equals 0, we should get first. Plug n equals 2, we should get this. Plug n equals 3, okay, when n equals 3, okay, 3 means okay, we are getting here, okay, because n equals 0 gives us the very first term, this. N equals 1 gives this. N equals 2 should give this. When n equals 2, negative 1 square is positive, x 2 plus 1 3 over 3. So this is it. This is the power series. In the power series impact Maclaurin series for natural log of 1 plus x. Final. This final answer can be written in slightly different way, because we started n from 0, this is good. Or if we start from n equals 1 through infinity, then when n equals 0 we are getting x raised to 1. Now we are starting from 1, so this will be just x raised to n over n, and we are supposed to get positive, so negative 1 to the n, that would produce negative, so plus 1. So negative 1 to the n plus 1, x raised to n over n, or this. So when we shift this n from 0 to 1, n from 1, okay, then we need to subtract 1 from each n, and n minus 1 is same as n plus 1, because negative 1 to the 2 is just 1, this or this.